Of congruences where the exponents in the system are pretty large, and that makes it rather difficult to just do, check 0, 1, 2, 3 all the way up through 9, the possible remainders, when you divide by 10. So I want to show you another approach here that I'll see what you think about it. All right, so we can reduce this statement. By the way, what we did is just multiplied these congruences together. Just like you can multiply equalities together, we multiplied the congruences together. Or it's x to the 28 times x to the 64th left-hand side, and then the right-hand side of the equality, and you can think of it like that, is 9 times 2. All right, so what we get right here is when you divide 10 into 18, you get a remainder of 8. And so you get this statement right here, and of course it's mod 10. I'll leave that out, but it's a to the 92nd is congruent to a mod 10. Now again, you could try to check. You could check 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's an approach, but the size of this exponent is going to make that computation kind of tedious. It's doable, but maybe a little difficult. So another approach is something I thought was pretty cool here. What we can do is just look at all possible congruences 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, those are the possible remainders. And notice we're looking at what that does with respect to the fourth power. Okay, so y congruent to 0 certainly means y to the fourth is congruent to 0. Y congruent to 1 means y to the fourth is congruent to 1. Now this right here, just so if you're not seeing what's going on with this, 2 to the fourth is equal to 16, right? So that's why you have a remainder of 6 right here, right? Okay, then right here, 3 to the fourth is 81. Okay, and it's like that all the way down. Now I will say, and this has a remainder of 1, right? So that explains the 1 right there when you divide it by 10. And all the way down, now when you get to these larger numbers, you may not know off the top of your head what 7 to the fourth power is, but you do know that it's equal to 7 squared times 7 squared. But that's 49 times 49, and 49 times 49 ends in a 1, right? Similarly, right here, this is 64 times 64, and 4 times 4 gives you a 16 at the end. That's why you get a 6. Same thing for 9 squared. 9 squared is 81, and 1 times 1 leaves a remainder of 1 right there. So what we've determined right here is that every fourth power, okay, every fourth power mod 10, let me just write it out right here. Every fourth power is congruent to one of 4 values, 0, 1, and you see how 6 and 1, and we get a 5 right here. But notice how it's nothing but 0, 1, 6, 5, 6. You see how 1, 6, 5, and 0 just repeat. So we know that any fourth power at all, is going to be congruent to one of 4 digits, 0, 1, 5, or 6, which is a nice little reduction there, right? Or you went from 10 digits to 4 digits when you raise it to the fourth power. Okay, the digits being 0 through 9. Okay, so these are the possibilities. These are the only possibilities modulo 10, right, for fourth powers. But you can see why that's super useful right here, because you can re-express this as, let me just go ahead and put mod 10 right here. Just you guys know it's mod 10, but just to be complete here. So this is mod 10. But you guys can see the step here that's going to kill this thing, right? You can rewrite this as a to the 23rd. A raised to the 23rd power. Properties of exponents, right? All raised to the 4th power. Okay. Which we know is congruent to 8. Okay. Again, y'all, it is mod 10. But notice that's not on our list. 8, a 4th power is not in this list, 0, 1, 5, 6. Now again, you may wonder, well, what's really going on here? Well, just think of it like this. Think of your y is a to the 23rd, right? See, that's just some number, all right, which is going to reduce to 0, 1 through 9, right? modulo 10. And so your y, and this would be like having y is equal to a to the 23rd, then y to the 4th would be, 4 times 23 is 92. So y to the 4th would be 8 to the 92, right? I won't write that down. But I think you guys see that. This step's probably unnecessary to show you. But so anyway, the conclusion here is since 8 is not congruent, I'll just put a little slash there. It's not congruent to 0 or equal, I guess you could say either way. 5, 6. Whoops. Okay, 0, 1, 5, 6, like that. Okay, and so the answer is no solution. The original congruence has no solution. I'm running out of room here. No solution. I'll write vertically, folks. Okay, so no solution is the answer to this thing. Just like you can have a linear system, non-modular arithmetic having no solution, meaning it's two lines that don't intersect. There's no solution to this system of equations, folks. So again, all the calculations really happen down here, and these are the only possibilities. 0, 1, 2, 3, 0, 1, 5, 6 are the only possibilities for fourth powers. This is a fourth power, congruent to 8, not in the list, no solution. Hope you enjoyed.